Hello and welcome to my final project for basic statistics. My project is an analysis of fundraising totals of a canvasser at the Texas Campaign for the Environment, and my name is Jack Ramsey. So some background, the Texas Campaign for the Environment is an environmentalist nonprofit based in Texas, and a canvasser, if you did not know, is somebody who goes door to door for a political or charitable purpose, doing a public education campaign, and also for fundraising is one of the purposes for canvassing at the Texas Campaign for the Environment. It's the main source of income, and it is where I work this summer and last summer. Daily fundraising totals for a single canvasser is what I'm going to be analyzing. The expected daily total for fundraising or donations, we call it standard, is $180. And that will come in handy when we do our hypothesis test in a minute. But first of all, the data, essentially the population, is workdays of an anonymous canvasser during her or his very long career at TCE, or Texas Campaign for the Environment. I asked my boss to send me a sample of data from a canvasser, and for privacy reasons, she did not disclose the name of the canvasser. However, she used a random sampling generator, a random number generator, to select 50 days out of this canvasser's very long career, and she sent those to me. So my data is a simple random sample of 50 days from this person's career. So first of all, for some exploratory data analysis, you can see on the right that there is, I've produced a histogram of this canvasser's fundraising totals, or my sample of size 50 for this canvasser's fundraising totals. The bin width is 75. The shape is clearly right skewed, but however, it looks pretty neatly unimodal, even though it is not approximately normal. The center appears to be around 200 or possibly a little bit more, and the spread appears to be from about $0 to about $575 with no outliers. Moving on in our exploratory data analysis, I've produced the 5-number summary and a box plot on the right. With the box plot, we can clearly see the long right tail, or the long tail above, that shows that the data is right skewed. The median, we can see in our 5-number summary, is 200.5, which we will definitely expect the mean to be larger than that because of the right skewness. And I've produced the mean and standard deviation below. We can see that the mean is 206.15 roughly, which is greater than 200.5 with the median, which is what we expected, and the standard deviation is 117.17 for this sample. Moving on to our questions and hypotheses, our question is this canvasser's mean daily fundraising total, the population mean mu, in other words, different from $180, which would be standard, the expected daily total for everyone at this organization. So that said, deriving our hypotheses, our null hypothesis is mu is equal to $180 at alpha equals 0.05. In other words, the null hypothesis is that this canvasser's mean daily fundraising total is $180. The alternative hypothesis is mu is not equal to 180. In other words, this canvasser's mean fundraising total would not be $180. These are clearly definitely testable with a two-sided hypothesis test by StatCrunch. However, I'm going to perform a confidence interval first for informative reasons and also to demonstrate the relationship between the two. And also, lastly, note that our sample size is n equals 50. We have 50 data points, a sample size of 50, which is large enough to apply the central limit theorem. So we do not need to make sure that our data are approximately normal and have no outliers because we have met the central limit theorem. So first of all, computing our 95% confidence interval. Essentially, I decided on 95% because we are doing a two-sided hypothesis test at a equals 0.05, which corresponds to a 95% confidence interval, since confidence intervals are two-sided by nature. I produced the results below, but first note that since we do not know the population standard deviation, we use T. With degrees of freedom equal to 49 since we have a sample size of 50. Now looking at the confidence interval that we've produced, which is from $172.85 roughly to $239.45 roughly, we can see that $180 is within this confidence interval. So we can already see that and say that we will probably or almost certainly reject the null hypothesis, assuming we did our confidence interval correctly. So yes, moving on to the hypothesis test, we can see from this hypothesis test that the sample mean is $206.15, just about, which is greater than 180. Nevertheless, though, as we expected, P is greater than 0.05. P is equal to 0.121. So since P is greater than alpha, we have insufficient evidence to reject the null hypothesis. The results are not statistically significant at alpha is equal to 0.05. So we are unable to reject the null hypothesis. Note that the T statistic for this hypothesis test, since we had to use T, was 1.578 roughly. Lastly, moving on to our conclusions and context, P was equal to 0.121, which means that there was insufficient evidence to reject our null hypothesis that this anonymous canvasser's average daily fundraising total was equal to 180. In other words, we were unable to conclude that their mean total is greater than or less than $180 because it was in the confidence interval and because our hypothesis test returned non-statistically significant results. Lastly, perhaps with a larger data set, we could detect statistical significance, but we would definitely need to collect more data. I would have to get my boss to send me a larger sample size. But perhaps for a next project, for this project, we did not prove any statistical significance, unfortunately. So yes, lastly, thank you so much for a great, even though it was super brief semester. Thank you so much. I hope you have a great rest of your summer.